Antonacci. I've had the pleasure of writing 2 books on the Shroud, one in 2000, one in 2015, but I'm also president of the Test the Shroud Foundation, which for decades has supported new and innovative scientific research on the Shroud of Turin. The foundation currently supports and is affiliated with the Shroud Research Group that Bob Rucker will tell you about tomorrow morning. Among our primary concerns is to support research on the Shroud and the Sidarium's linen, cloth, blood, watery fluid, pollens, limestones, and of course the Shroud also has charred material and sewing threads. So the idea is to test all of those materials and control samples first, and then hopefully if you get positive results and you can repeat your results over and over with control samples, that you would get some Shroud samples and Sidarium samples. Neither of these cloths nor the materials on them have been tested at these levels. Testing at the molecular level by hyperspectral and multispectral imaging would allow both cloths, all of the materials upon them, as well as all the materials that have already been removed from them, to be definitively identified as never before. One reason that such stunning identification can be made is that materials today with this type of technology can be examined at the infrared, visible, and ultraviolet levels simultaneously. These new techniques would allow scientists to not just identify every fiber on every thread, but what is on every fiber of both cloths. This technology would allow the individual chemical or elemental compounds to be identified on both cloths, the blood marks, the watery fluids, and other materials. Of course, the Shroud is much larger than the Sidarium and contains greater quantities of these materials. The Shroud, for example, had an extensive amount of charred material on it from 16 different locations. These were removed in 2002, and they're now kept in 42 vials in Turin. Oh, they were on there, okay. And these charred materials and anything that was vacuumed with them or on the materials over all the centuries should be initially examined at the molecular level. In the extra session tomorrow afternoon, we'll concentrate on how merely examining these charred materials at the atomic level could yield some of the most important information ever acquired from the Shroud of Turin. The Shroud also has approximately 13 feet of sewing material that you see on the bottom strip. Look at that. It's about 13 feet of sewing threads. Below the, well, you'll see that this long seam has been carefully folded and sewn from the reverse side of the Shroud so that it appears flat and hardly noticeable. On the top picture, that's from the frontal view of the Shroud. You hardly notice that. And like I said, it runs all the way across. Because it's sewn from the reverse side, though, this also causes a raised or rolled effect that you see on the bottom. And Mechtal Fleury-Lamberg went out of her way to point out that this is distinctly similar to the hems of cloths that were found in the tombs of the Jewish fortune at Masada, which was destroyed in 73 AD. The part of the Shroud that's between the side seams And the edge of the cloth, of course, is the side strip. If you remove the backing cloth from the shroud and you examine the back of the side strip and the back as well as the front of the main part of the shroud, you could definitively tell whether the side strip is an original part of the cloth, which Fleury-Lamberg thinks, or it is added to the cloth. And it would also give scientists the information to know what those sewing threads consist of, and you could test them at the atomic level, and all you need is a couple loops, and there's 13 feet of loops. This is very minimally invasive atomic testing, and the molecular testing is completely non-destructive. By the same token, if you examine both sides of the shroud on the front and the back, you could also definitively say, indicate whether the shroud was invisibly rewoven, which photomicrographs, X-ray fluorescence, and radiographs from 1978, as well as visual inspections of both sides of the cloth by many experts and observers in 2002, indicate that it was not rewoven. But you could get a definitive answer on that. In fact, it could test, well, you could identify whether any natural or artificial products were involved or affected any part of the body image, the radiocarbon dating, or the appearance or composition of the blood marks. You could definitively answer all those questions. You could really answer all the outstanding issues, really, probably, on the shroud. You could also, you could put this on the burn holes, water stains. You could find additional pollens. The backside has never been examined for pollens. You could probably find lots of small items of limestone. The backside would have been laid on the bottom of the tomb. It's never been examined for anything, really. Other things you could you could test whether because it's so extensive and so definitive, you could probably at least shed new light on or definitively resolve whether the body images are comprised of oxidized dehydrated cellulose with double bonded carbon and oxygen atoms that used to be single bonded, whether some of the molecular bonds in the non-crystalline regions of the cellulose have broken and reformed. That would have been caused by neutrons, or the types of limestone or pollen or other material on the shroud. This technology could add clarification to some of the previous identifications of certain pollen species on the shroud. Whether there's two sets of water stains on the cloth from two different events in two different eras. Whether discoloration is found on the where the coin features and flower parts have been identified by some people. You could also tell whether there's discoloring on the reverse side of the shroud at the hands and the face, if you examine it at the molecular level. It could also tell you what areas to avoid, such as like starch or wax that can chemically bind to linen and not be visible with the naked eye and not be removed by pretreatment cleaning processes, but this could identify such items like that on the shroud. It could also tell you places to avoid. It could also tell you places to concentrate on where you want to test at the atomic level. You're looking for places that have high amounts of chlorine or calcium or nitrogen. things like that that convert to radioactive atoms. We'll get into that in more detail tomorrow afternoon. This is just some of the preliminary things to look for. I mean, this technology could non-destructively examine the whole cloth and give you, many times more information than has been acquired since 120 years ago when scientific technology was first applied to the cloth. I first wrote about molecular microscopy in depth in 2015 when this was the top of the line type of equipment that I was aware of to examine the shroud with, but there's obvious problems to try to examine a piece of cloth that's 14 feet long and 3 inches wide with such a small focal viewing mechanism. But look, now what they got. Yeah, you said it. That's just what I said. Wow. They've even got handheld devices. It won't tell them as much as that thing, but it still tell you a lot of things, you know. So those problems, the market is actually working in our favor. I'll tell you something. You could get such detailed, multiple amounts of information, say from the blood or the watery fluid on the shroud and the sudarium. I'm told that you could get like a virtual fingerprint of these vital fluids on both cloths. You could tell whether it's the same individual.
Mark, with that rig, I'm imagining that if you had the shroud, that the shroud would slide through.
Yeah.
And it looks like we've got 2 lights focusing down on, I presume, a very, very narrow band, and the information would then be collected at that spot.
I think so. Other people here could probably tell you better than I could. But yes, I'm told you could slide the whole shroud under that.
And then flip it over and do the same thing.
Sure.
Thank you.
You could even take control linen and irradiate it with every form of low energy radiation that you can think of. And then examine it at the molecular level with something like that. And then you could artificially age it and examine it again and see if you see more things like oxidized dehydrated cellulose and conjugated carbonyls and that kind of stuff. So you could just get a wealth of information with completely non-destructive techniques. It could give you a lot of indications that radiation was involved, that the shroud was, and the sudarium was irradiated with some forms of radiation. More importantly, examining the shroud and the sudarium at the atomic level could definitively prove whether these cloths, the blood, the watery fluid, and the other materials were irradiated with a unique form of radiation that wasn't discovered until the 20th century. While this form of radiation would not have created the body image, its release probably would have released other things. I'm talking about neutrons held together by the strong nuclear force. They're held with protons, things like protons, maybe electrons, alpha particles could have also been released that would cause an image. But you could tell definitively if you tested at the atomic level in these materials whether the shroud and the sudarium was irradiated with neutrons, whether the source of the neutrons was the body, the amount of neutrons that each location received, the real age of the cloth, when this event occurred, and possibly even where it occurred. And if you have all that information, and you have a miraculous event, you have better evidence than DNA evidence. You've got the identity. These would be, to me, the most immediate areas you should go to testing for. I think another thing to do is test for whether neutrons causes the blood to stay red over time. And that wouldn't be that complicated to do. It's been theorized that it is. It's never been tested. I've seen a lot of experiments that Kelly did, and it was very, it's interesting to see what would happen if Goldini said it would, but I could never get a set of his color pictures of his results. I could only see them in black and white. And so it'd be interesting just to repeat that. And he lays out the procedure he did in the 2008 conference proceedings. So it'd be interesting just to see if it did. I agree that scientific protocols, that if you try to do DNA testing, they want 12 samples from different locations, and the Shroud's just, it's just been handled too many times. I don't think you could ever 12 pure parts, but it would be interesting to see if they repeated another known spot, like they took the blood before in '95, I think they tested it, and that was from the back of the head that Giovanni Rigi took. You could probably get another piece that's fairly pure from the side, but I can see where DNA is not your top priority. And there's been I would think testing the Shroud at the molecular and atomic level is your next high priority and could really answer all the critical questions about the Shroud. That's about as much as I can do in about 20 minutes, but I'll be glad to take any questions.
So the big question is, why aren't they going to let us test it?
Well, to me, you have to do these tests on control samples, show the results, then you go and ask them, could you? And we haven't really presented that question to them. I think they're correct in not doing another carbon dating test right now. I'm all for carbon dating, taking carbon-14, carbon-12, but only after you have taken, say that it was irradiated, it was irradiated with neutrons, you could test the chlorine-36 to chlorine-35 ratio and or the calcium-41 to calcium-40 ratio, and then take the carbon-14 to carbon-12. If you take the chlorine-36 to chlorine-35 and the calcium-41 to calcium-40 ratio, you'll know how many neutrons that location received. You can take that same sample and know how many extra carbon-14 atoms it got. Then you can tell when this event happened and that sample you know was irradiated. And it's with the same technology as carbon dating.
So you wanted to do some other experiments to sort of say, this is what we've discovered.
We want to demonstrate.
And then go. Okay.
We want to take a piece of linen, say, and irradiate it with known amount
Do some different stuff and say,
of neutrons, and then confirm that these can be measured and measured accurately.
Okay.
And then you would know how many additional carbon-14 atoms you got, and you could really tell a lot. And the blood would tell you more than anything. The blood is much richer in chemical elements.
Mark, so are you proposing to use like a research reactor to provide these neutrons to basically expose the cloth?
Not the Shroud, the control cloth.
A controlled sample. Because in 1998, when I was working with Sue Benford at the Ohio State University at their Department of Nuclear Physics, where they had the reactor, we actually bombarded linen with neutrons from their reactor, and even from the fission reaction, we almost destroyed that linen cloth, because what we wanted to do is see if we could increase the mass of carbon-14 using this thermal neutrons, and we almost destroyed that linen cloth. And one of the things that I've been discussing, I discussed with Robert Rucker back in St. Louis, is that there is very low neutron activation. And the thing is it has to be so low that you're not going to create a lot of those carbon, or not the carbon, but the chlorine atoms and all those other isotopes.
Art Lynn wrote a paper in 2010. It's being submitted to a peer-reviewed journal now, but at the conference outside of Rome, and he proved with a relatively low amount of neutrons that it would increase the age 1,200 years or far more. It would date into the future if you took a modern piece of linen. No, you don't have to blow it to smithereens at all. I mean, he's demonstrated with this with several
Just
pieces.
based upon the experiments that we did at the Ohio State University, and even when we were moderating those neutrons from the, or through the water bath, it seemed like that the energy or the velocity of those neutrons were too high, where we were almost destroying that linen cloth.
I don't know where you're at, and obviously I'm not a scientist, but no, read Art's paper. It's 5 authors on there, and I've seen the linen. It doesn't destroy it, that kind of stuff.
So it's been using like a lower, or slower.
Yeah, and I don't know what you were using or where it was doing it, but.
Thank you so much, Mark. I'm going to have to stop you there. But the discussion can continue tomorrow.